In human societies, equality and degree of freedoms are two important issues, and many people consider it very seriously. But what happened to the world of atoms and molecules? Do atom and molecule consider equality and freedom seriously? Well, the answer is yes, as it has first reviewed by famous physicists Maxwell and Boltzmann. Okay, actually, in statistical physics, you will find a relevant basic law called the equipartition law, which states that at a thermal equilibrium state, each degree of freedom within the molecules will have the equal share of their internal energy or their own property. Okay, that amount is exactly equal to half kT, where K is Boltzmann constant and T is the absolute temperature. So that is why when you study the ideal gas law in chemistry or physics, you will see the formula that the average kinetic energy of each molecule equal to 3/2 and times K and T. Okay. So where does this 3 come from? Well, in this particular case, the 3 is represent the degree of freedom of the particles. Okay, or you can call it the molecules, right, without size. So if you consider very small molecules in space, and you can only see, they can only do translational motion, okay? Because the size is insignificant, so the rotation doesn't contribute any degree of freedom. So the 3 is determined by the independent direction the particle can move. In the case of the 3-dimensional space, that number of degree of freedom is exactly 3. Okay. But for the molecule have more than 1 particles, in this case, you can see this 2, 1. So these molecule, not only can they translate in the 3-dimensional space, but they can also rotate, okay? They can also rotate. So that provide additional degree of freedom. In other words, the family is not a single. It's not a single. They are couples in the couples, right? So for the couple, their degree of freedom will increase. So because after all, they can either rotate, but also they can also vibrate. So the chemical bond, the bond length, the length of bond is not rigid as in this model. The 2 atoms can actually vibrate along this chemical bond direction. So therefore, additional degree of freedom must be added. In other words, if this couple have an income of $1,000, and these $1,000 were equally distributed to the degree of freedom, not into 2 parts, but in this case, it's more than 3, 4 parts, okay, at least 4 parts, all right? In the case of, let's consider another molecule, which is blamed, it has been blamed to be responsible to warm our global temperature, is carbon dioxide. Okay. Carbon dioxide has 3, the molecule of carbon dioxide is made by 3 atoms. And the dark one is carbon, and the 2 red one are oxygens. For the carbon dioxide, you can see that apart from the translation in 3D space, 3-dimensional space, then they got 3 degree of, that is the basic 3 degree of freedom. They can also rotate, you can see, they can also rotate. And the rotation were also, so that's why they have more freedom they have more degree of freedoms. Okay, so unlike the single, the degree of freedom is confined to 3 in 3D space, but for the carbon, it's just like a single child. It looks like a single child family. They have 3 members, but their degree of freedoms is not 3, but 6. I can tell you why. So apart from the translation in space, okay, that have 3 independent direction. So that implies that they had at least 3 degree of freedom. In addition, they can rotate. That get a contribution to another one, that is 4. And besides, these two bonds, the lengths can periodically change or can vibrate, in other words. And in addition, this angle can periodically change or bending. So the chemical bond can not only compress and expand, but also they can be burned. So this angle can be changed. So altogether, if you look for the textbook, the degree of freedom for the carbon dioxide is 6. So in other words, for any reason, if the carbon dioxide molecule absorbed a certain amount of energy or had get money, say $1,000, so they will immediately start redistributing this amount of the income to the 6 part, into the 6 equal parts. For example, the bending of the carbon dioxide molecule is responsible to the absorption in the far infrared radiation centered at 15 micrometers. Okay, so in other words, the carbon dioxide near the surface of the Earth, especially very close to the surface, within the first 100 meters height, where the density of any molecule in air is highest. So the carbon dioxide can absorb certain amount of the thermal radiation from the Earth. Okay, and this radiation absorption is very effective, because that the bending frequency is very close to the peak of the radiation peak by the Earth. So therefore, that is a key issue. People trying to explain that why the carbon dioxide molecule was relevant to the global warming. However, their explanation is based on oversimplified assumption. They assume that the radiation energy absorbed by the carbon dioxide were immediately re-emitting to the space. So they built some very complicated model in order to predict what's going to happen, the average temperature of the Earth's surface in the future. But they have made, their modeling is obviously, they haven't taken into account of the consciousness concern by molecule of the quantity and the degree of freedom, right? So in short, once the molecule, in this case, carbon dioxide, absorbs any amount from radiation, okay, or through condition from additional, for example, some molecule, water molecule is faster than others, and they can also absorb the energy from outside, from thermal condition, or directly from the source of the radiation. In this case, is Earth's surface. But once the molecule, in this case, carbon dioxide, absorbs this amount of energy, they should immediately redistribute this surplus, this unexpected income among the 6 members called 6 degree of freedom equally. That is called equality in the carbon dioxide. Okay. So the present modeling and the global warming modeling, that they didn't consider that there's such a law of they don't care. Okay, they probably consider their freedom and equality, but it would appear they haven't considered the equality and freedom deserved by these innocent molecules. You see. So if you can apply this equal partition law originally proposed by Maxwell and Boltzmann, then you not only can you explain that is a formula for the average kinetic energy in the ideal gas model, which is 3/2 kT. In the case of carbon dioxide, remember, if the degree is 6 for carbon dioxide molecule, what would be the average energy formula for the molecule of carbon dioxide? Think about it. Yes, it is equal to 3/2 kT, or simply 3 kT.